remember I told you we have 4 different equations that we're going to use for exponential growth and decay. We showed 2 of them. Now these are 2 special cases. Okay, so these are we call them the doubling and the half-life. Okay, so these 2 equations we only use them if the population or whatever it is doubling, or if it's half-life. Okay, halving. That means you're losing half of the population every single time. So, as per the previous equation, I have a 0, I have my base, and I have my exponent, right? So A is still your final amount, and A0 is your initial amount. Now, if you have doubling, your base is going to be 2, because you're doubling, okay? If you have half-life, your base is going to be 0.5. It's half. Your exponent is going to be t divided by some. Now, that's something in case if it's a d, it will be in time. So let's say if your population doubles every 3 days, then d will be 3. So you have to divide t by 3. Okay? If your half-life is, let's say, every 5 years, let's say, then h is 5. Okay? So t, d, and h, they are your doubling time and your half time. What's the time? It takes for population to double, and h is the time needed to reduce by half. Okay? So in the question, they either give you the doubling time or the half time, or you have to look for it. If you have to look for it, then they will give you everything else. They will give you t, a naught, and a. Before we get to the word problem of solving half-life and double time, I want to teach you a method that you can solve for the exponent without actually doing trial and error. See how in the previous question we did trial and error? Right? There is a mathematical method that you can use where you don't have to do the trial and error. You can actually plug it into the calculator and it will be done. Okay? This is not part of the curriculum, so you don't have to use it. You don't have to learn it if you don't want to, but it's for ways for you to cut corners, right? And shorten time. So if you're looking for the exponent, what you have to do, there's a button on your calculator called log, so L-O-G. So find that. L-O-G. Yeah.
Yeah.
So you're going to have to use that. And the way you use it is you do log of the answer divided by log of the base. Okay? So if you're looking for the exponent x, you do log of y divided by log of a. So let's look at an example because they make more sense when you're looking at an example. Like this is similar to the example that we just did earlier, right? Where you had 2.1 something equals to 1.041 to the power of x. You remember that? Okay. So this is a similar example. I'm looking for my exponent. So all what I have to do is log of 5 divided by log of 1.06. No. 1.06.
Oh, yeah, sorry, yeah. Cool.
So I didn't have to do any guess and check. All what I have to do is plug in my numbers in the calculator. I got my answers. Make sure that you know how to use that on the calculator. You got it? Okay. Now, find the second one. What do you do?
2x times 2x and then
So 2x would be what?
log 25 divide log 0.20.
And what do you get?
I got
Yep. So that would be negative what?
105.68.
So that's 2x is negative 105.68, right? If I want to find x, what do? Divide by 2. So this is one way to actually solve this. There is another way. I'm going to show you both ways because I think the second way would be more useful for you guys. Okay, do you understand that one? So I did log of the 25 divided by the log of the base, and then I divided by 2. Do we all understand that? Okay. Another method that you can use for this, can I have your attention? So another method is using your exponent laws. Okay? This is as writing this, correct? Because when I have exponent to the exponent, what do I do with my exponents? Multiply them. So that's 2x, right? Okay. Now you can do that on the calculator. What do you get when you do 0.97 squared? You get this? Okay. Now you have x by itself. Okay. So all that you have to do, log 25 divided by log this, you got the answer. Okay. And your answer should be exactly the same as the above, which is negative 52.84. Okay, so this is, I'm solving the same question in two different methods. Whatever method you feel more comfortable with, get to learn.